Hello, everyone. Thank you for being here with us today in this Snack and Leg webinar. My name is Danai Petrou, and I am located in Copenhagen, Denmark, where I work as a sustainability consultant. I work here as part of the sustainability team, but actually before that, I used to work in London. I was in sustainability and climate change team. And in both teams, I mostly work with LCAs and also LCCs. LCAs in Denmark are a particularly a hot topic right now, as all the new buildings from this year onwards need to submit life cycle carbon assessment calculations as part of their planning applications. But also here we work with energy modeling for new buildings and master plans, and also existing buildings as part of their net zero carbon pathway. We do net zero carbon studies for existing buildings and sometimes also in neighborhood scales, and try to extend in the scope for energy, embodied, transport, and anything else that seems appropriate. We work a little bit with science-based targets and also a bit with daylight and microclimate. Moving on to the project. Today, I will try to give you an overview of how we work to reduce the carbon footprint of a mixed-use building by more than 50%. The design for this building took place as an architecture competition entry for a new office and mixed-use building in Oslo, in Norway. And this happened in collaboration with Schmidt Hammer Lassen architects. As a design team, we reached only to place number 2, but nevertheless, we learned a lot along the design process, and this is what we came to share with you today. Before we continue, I would also like to thank Schmidt Hammer Lassen architects for the renders and the visuals that you will see throughout the presentation. So we will start with an overview of the design intentions and the sustainability targets, and then we will explain which design principles contributed the most to the project carbon reduction and go through them one by one, and then we will close with an overview of the final design proposals and lessons learned. So the site, as you can see in this slide, is located in Norway, in Oslo, very close to the central train station. It currently comprises of a parking building with some limited office areas on one side, on the front. Aim of the design is for the site to be redeveloped to an office building with also some large retail and some public areas, and also a small bus stop area on the ground floor. That was the brief. And the competition brief also includes demolishing the existing building and designing a new one in its place, because there is a very low floor-to-ceiling height on the existing parking building. It was about 2.3 meters. So it was not very appropriate for the character of the new design. The new office building is aspired to comply with the Norwegian future build requirements. This is a sustainability scheme, and it generally requires for new buildings to achieve very low whole life carbon emissions, incorporated at least 50% reused and reusable components, and achieving a significant increase in local biodiversity, among a few other criteria. When it comes to its carbon performance, the new buildings are aspired to perform 50% less than the current practice in the industry, while simultaneously looking 10 years ahead into the future. And this means that the carbon target for our design was a bit less than 225 kilos of CO2 per square meter, or for the Danish audience today, the equivalent of less than 4.5 kilos of CO2 per square meter per year. This is the primary carbon metric in Denmark. In WSP, we always seek to align our designs and advice with sustainable development goals. And for this project, alignment was pursued with goal 3, good health and well-being, 9, industry innovation and infrastructure, and 12, responsible consumption and production. So, in the early stages of the design process, we collaborated closely with the architects to understand, first of all, which are these broader design initiatives which have the largest potential to cut down on carbon for this project. The first possibility that we decided to explore was whether it is possible to reuse, that's the first one, any of the precast concrete structural elements from the existing parking building before this becomes decommissioned. And these elements, we were thinking if we can use them for the construction of the new basement areas, which are required anyway by the competition brief. They were quite extensive and therefore potential carbon hotspots if we didn't include a solution for them. And then moving on our considerations from the substructure to the superstructure, we look for ways to minimize, to reduce the required quantities of the structural materials. And that's why we decided to include some early computational design analysis on some different structural grid scenarios. We will go through them later. And then we also explored various structural systems, concrete, timber, or hybrid. And we wanted to understand which of them could be efficient when it comes to resource use. The next design opportunity that we dived into was including timber in the structural and architectural design. And this is because by reviewing the Norwegian LCA methodology, the use of timber is highly advantageous when it comes to accounting for its biogenic carbon storage. It's not like that in the UK, it's not like that in Denmark. So how they calculated is that the tree, which replaces the tree that was used in your building, gradually grows and sequesters carbon from the atmosphere. And then this carbon is accounted in the use phase of the building's life cycle. So the minus doesn't go to the stage A, but to the stage B. And then later at the end of life stage, timber is assumed to be burned and emissions are emitted back into the atmosphere. This is also how it is in Denmark. However, in Norway, the waste timber is largely used for the heat generation of the local district heating system. And therefore, their methodology says that the allocation of these emissions from burning the waste timber from the building goes partly to the new building and partly, and as a bigger percentage, to the local district heating emissions accounting. So your building only gets credit for less than half of its end-of-life emissions from timber. All in all, it was concluded that timber is a crucial tool for cutting down carbon emissions, and we should try to include it as much as possible. And finally, energy. Carbon emissions from electricity and heating consist generally about 1/3 of the overall carbon emissions, more or less, of a new constructed building today, and therefore achieving an as low energy as possible operation is crucial for achieving the carbon targets. And a synergy between passive measures, low carbon heating sources, a mixed mode ventilation heating cooling system were explored, as we will see later. So to wrap up, these four, reuse, reduce, timber, low energy. These four are the four key design principles for reducing carbon emissions. And in the next slides, we will go through the specific solutions that implement these overall principles. Starting from the reuse. The existing multi-story parking garage, as we said, is constructed from long-span precast concrete elements, which provide the opportunity for reuse of the structural component, where it has been considered, and they have been considered to be reused specifically as part of the proposed basement level floor structures. Circularity of structural elements in this way is not very new, and there is a precedent in Oslo. There was this development, Christian Augustgate 13, which is Norway's first building where the reuse of building materials and circular solutions has been used on a larger scale. So by considering such a solution, it is estimated that we are saving approximately 90% of the embodied carbon in comparison to like a standard construction of concrete floor slabs, not accounting for foundations or retaining walls, just the slabs. And then, after reusing as much as we could, we worked on solutions which minimize the structural material used for the construction of the upper floors now. Initially, we compared a series of structural grid options on the material quantities required, and therefore their carbon intensity. So the narrower grid option on the left was 6 by 6 with thinner columns and thinner beams and 3 rows of columns. And then the widest one, it was a 6 by 12 meter grid, only with 2 rows of columns, but then the beams bridging the largest, the long span, they're from steel. And the rest of the options that we tested lie in between. So the results of this analysis showed that for this building geometry, we were going for an atrium typology, so not an especially long building. It is more efficient with a narrow and the leaner grids, the 6 by 6 or something equivalent. And the long span hybrid timber solution, while providing a benefit to have like this clear open floor plate, it would increase approximately 20% embodied carbon content. And then as the design moved further and we specified the structure, we moved to another method to reduce the material quantity. And this was to adopt the modular CREE system. So this consists of a hybrid timber and concrete floors, which are supported by steel beams here internally and timber posts along the facade. There's a concrete topping to the timber floors, which provides additional mass and improves the acoustic and fire performance between the floors. The proposed arrangement is based on a 7.5 to 7.2 grid, and then this is divided by 3. And yeah, so this suits the proposed 2.5 planning grids and still offers a pretty flexible open plan arrangement. The proposed system was selected also because of its carbon and structural efficiency, but also because it responded to this high quality design intent with crafted detailing of all of the exposed details. And here we can see an overview of the basements from the precast concrete elements and then the CREE system. And then here the roof. The roof structure consists of glulam beams, and lateral stability is provided also by cross-laminated timber and in wall elements around the staircase and the lift course cantilevering from the base. The choice of the window frame materials was also made in favor of timber, with 87% of all windows designed to be timber framed, but also some aluminum ones used in some curtain walls. And finally, the last layer of the proposed low carbon building designs aim to achieve a low energy performance. The proposed passive design measures in this design include using the thermal mass provided by the concrete layer of the slabs, and this has been combined with a geothermal heat pump based. It was a system for heating, cooling, and ventilation. There is some heat recovery, which takes place during winter at the top of the atrium where the warm air naturally rises, and then during summer, as you can see on the right, the openable windows on the rooftop with integrated shading help to mitigate overheating naturally. Overall, the carbon footprint of the proposed design was reduced according to the Norwegian LCA methodology to approximately 210 kilos of CO2 per square meter, which is a reduction of approximately 62% when compared to standard practice. And therefore, the design actually achieved compliance with the future built carbon requirements. Wrapping up with some use of the proposed design, you can see the CREE system, the 2.5 grid, and the glulam beams for the roof, the concrete floor slabs, and some facade materialities. Thank you very much for your time this afternoon, and shall we proceed to questions?
Thank you, Danai, for a fantastic presentation. So just reminding again the housekeeping items, if you can please continue log your questions in the question box on the GoToWebinar control panel, and also the presentation slides are available to download in the handout box. I will start with the first question. What is the design life of the building?
For the Norwegian methodology, is 50 years. It's usually between 50 and 60 years, depending on the country. Denmark, we also have 50. UK, I think 60. But yeah, for Norway, it was 50 years.
Thank you. The next question is the end-of-life carbon impact incorporated into the whole life carbon footprint?
Yeah, it is. But I understand this question is because we expect that when we have timber, the emissions are usually very low throughout the life, and then at the end of life, where it's burned, it goes up. But because in the Norwegian methodology is a bit different, it has this advantage in how you account for the biogenic carbon storage. The end of life, it is included, but it's less than we would normally expect.
Thank you. Does laminated timber use is a threat in case of fire outbreak?
I'm not a fire engineer. I know that it's definitely something to be designed for. This particular building, it's a mix of CLT and concrete, and this should be easier to mitigate when it comes to fire risk.
Thank you. Could you explain how the Future Build program estimates the embodied carbon of a typical practice 10 years in the future?
This has to do with the targets. So they have made this timeline of how do they project for the current best practice to evolve. So right now we have a best practice that is around, I don't know, 500-600 kilos of CO2 per meter square. But then they expect that this current standard industry practice will improve. And then what they ask you is to be 50% less than that, not today, but in 10 years in the future, so that when your building gets complete, you're ahead basically of the current practice. It's just the way that they have set up their target scheme.
Thank you. What is the estimated remaining life of the reused precast floor?
We have the parking building was not an old one. We don't know exactly how much it would be, but it could be less than 50 years that it's there. So we have assumed that for the 50 years lifetime that that it's the LCA life for the building. We have assumed that the beams would hold another 50 years because normally concrete is 100, 120. So we accounted that they would last for another 50 years for sure.
Thank you. How can you protect the timber from rain and snow during construction?
Yeah, I cannot answer that. It's towards the end of life and the contractors that take these decisions.
Sure, no problem.
But it happens. But I cannot answer this question. It's not what I work with day to day.
Sure, no problem. Sorry, we have a lot of questions. What was the operational carbon limit of the building?
I have to check.
That's okay. We can go back to this individual. Oh, sorry.
Around 100 CO2 per square meter per year, and I'm checking this slide because we did use the future build requirement, like their energy requirement for the LCA calculation. So it was around that much.
Thank you. What other options did you explore, and what criteria did the client use to choose the concrete timber solution?
The other solutions that we explored was the standard hollow core slabs and precast beams and columns. The second one was all CLT and glulam, and the third one was the hybrid. And the client only because it was a competition design for a competition, we only discussed with the client the last option, the one that we had actually chose, the hybrid, the CREE system.
Thank you. How do you ensure that the client or the customer accept a low carbon solution which includes recycled and reused components?
In this particular case, it was part of the competition brief that we comply with the future build requirements, and this already include having a very low carbon footprint. And actually, there is a requirement to use reused and reusable materials as per this future build scheme. So the client already wanted or was open to exploring solution in this area.
Thank you. Why do the timber concrete slabs represent such a lower embodied carbon than traditional hollow core concrete slabs?
It's because there is less material quantity. So this slab that you can see is actually very thin because it has those beams around it. It's very narrow and long, and it has those beams that are on one direction, it's concrete, and the other one is glulam. And then the panel that goes on top, it has a very small width. So in terms of material that is used is less than a hollow core slab. And then also because it has timber as part of it, it also gets a minus. This is how it gets so low.
Thank you. Can you clarify what does CREE stands for, the CREE?
I don't remember. I'll check. I don't
No
remember,
problem.
but it's a brand.
Okay, thank you. Do you assume all structural parts are good enough in the state to be reused?
One of my colleagues, who is a structural engineer, he went on a site visit and in the beginning of the process, and because it was a new building, it was just from visiting the site that we had that he judged that there is potential there. But if this was meant to be selected and moved to the later stage, there would be more thorough examination of that.
Thank you. Which structural grid options did you go finally for? Was that the 7.2 by 2.5 structure grid for when using hybrid and concrete slab?
Yeah, it wasn't the 6x6, but this analysis showed us that the narrow grid we go is better than the more wide. But then we followed the grid of the CREE system, and it was a bit more narrow on just on the facade, and this helped with reducing the section of each of the columns and the beams. But then it allowed for the spans to be a bit bigger inside. So then you could still have a functional layout plan in between the columns.
Thank you. Would you know if reused material is an issue for building insurance providers?
I don't know that. I haven't worked with that.
Okay, no problem. We can find out later and let you know about this.
Yeah.
So we have some additional questions that will be answered later on today. So thank you, Danai, for a great presentation. Thank you, everyone, for joining us today. We hope you have a wonderful day, and we hope to see you in our future upcoming webinars. Thank you so much.
Thank you very much, everyone.
Thank you.